All right, we're going to pick up on the 5.1 notes. We were talking yesterday a little bit about probability and then specifically how to use a simulation to determine whether the results of something were likely to have occurred or not likely to have occurred. Okay, if we perform a simulation multiple times, we can then analyze that to see whether we think the results were likely or unlikely. So let's pick up here with chapter 4. This is a NASCAR example. It says, in an attempt to increase sales, a breakfast cereal company decides to offer a NASCAR promotion. Each box of cereal will contain a collectible card featuring one of these NASCAR drivers. Okay, so the card is either going to be a Jeff Gordon card, Dale Earnhardt Jr., Tony Stewart, Danica Patrick, or Jimmy Johnson. The company says that each of the 5 cards are equally likely to appear in any box of cereal. A NASCAR fan decides to keep buying boxes of cereal until she has all 5 drivers' cards. She is surprised when it takes her 23 boxes to get the full set of cards. Should she be surprised? Design and carry out a simulation to help answer this question. Okay, so the way these typically work is we have the results of something happening, like in the the previous video, I was talking about the golden ticket lottery, and they were selecting 2 tickets out of the 95, and both students were from the AP Stats class, and so we were running a simulation to see how likely it is that that would have occurred by chance. And so here we are, this girl had to purchase 23 boxes of cereal for her to get each of the 5 different cards. We want to figure out, is that unusual that she had to purchase that many, or is that something that totally could have happened by chance? And so again, in the box, you see these are the 4 components to creating and designing a simulation, and we're going to walk through this one from scratch. The one that we did yesterday had some of it done for us. A little bit of this is done for us here, I guess. It says, what's the probability of needing to buy 23 or more boxes of cereal to get 1 card from each driver? Okay, so this is kind of our statement of what we're looking for. I'm going to go ahead and write that in the form of a probability statement. We're going to let X represent the number of boxes of cereal. Okay, and she had to purchase 23. So we're just going to say, what's the likelihood of needing to purchase either 23, or we'll just go even more extreme than that, or greater than 23 boxes, okay? Because certainly if buying 23 boxes, if we discover that that's an alarming number of boxes to have to purchase in order to get the 5 different cards, then we would probably conclude that anything more than 23 boxes is also alarming. So we'll just say, what's the probability of needing to purchase 23 or more boxes? Okay, now here's our plan. Okay, so I have this spelled out for you as well. We're going to use the calculator's random number generator, the randint feature, and we're going to simulate, actually I think we're going to simulate 45 trials. Okay, and we're going to do this collectively as a class so that you yourself would not need to do this 45 times here. Okay, we're going to assign each driver a unique number. And so you can see underneath here, we've assigned Jeff Gordon the number 1, Dale Earnhardt Jr. the number 2, etc. Okay, we're going to record how many trials it takes to get all 5 values. That means all 5 drivers. And we're going to record the total number of digits required each time. Okay, all right, so let's go ahead and flip to the next page here. Okay, keep in mind, these are our labels. Each number, 1 through 5, represents a different NASCAR driver. Okay, so in class, I would have had you simulate this just 3 times on your own, and then we would put all the class data together. So I'm just going to demonstrate this here for you. On the calculator, I would have chosen the random integer feature, okay, which I believe is under the math button and the probability menu, and then it's option 5, okay. and you would need to say, okay, what's the smallest number that we want generated? That would be a 1. The biggest number would be a 5. And then I want to generate 5 numbers, okay? All right, so if we were to do that, let's see here. Actually, not generating 5 numbers, I apologize. I'm just going to generate 1 number at a time, okay? I don't know on the older calculators if there's a spot for this. I know on the newer calculators, it asks you for n, and we'll just enter a 1 in for the n. So this is the lower, this is the upper number, and this is just me purchasing 1 box of cereal, okay? And so I'm going to go ahead and press enter, and then it's going to spit out a number 1 through 5, okay? So it's going to give me, I'm going to go ahead and do this right now here. Okay, so now you can't see this on the screen, but the first number that my calculator gave me was a 5. Okay, I think that coincided maybe with Jimmy Johnson. Okay, so I'm going to go ahead and put kind of a little tick mark right here, meaning I have his card now. Okay, and then I'm going to go ahead and repeat it again, and it now is giving me a 2. Okay, so that means that we now have Dale Earnhardt Jr.'s card. Okay, and so then I'm just going to, every time you hit enter, it'll just do it again and again and again. So you don't have to keep hitting the math button and the probability menu. Now it gave me a 4. Okay, gave me a 3. Gave me another 3. So I have a repeated card there. Who's number 3? That is Tony Stewart. So I have 2 Tony Stewart cards. I still need this first one here, which is Jeff Gordon. Okay, so I'm going to keep generating numbers. Every time I get a number, I'm putting a tally mark with what card. Okay, there I got number 1, which was that first Jeff Gordon. Okay, so then I'm going to record down here. This represents the total number of boxes that I would have purchased for this first simulation until I got a set of all 5. So it looks like there it took me 7 boxes of cereal before I had each of the 5 different drivers' cards. Okay, and so then in class I would have you do this 3 times yourself. I'm just going to share out another sample of data when I did this before, and this would have taken 9 boxes of cereal. Okay, I think another time it took 13 boxes of cereal. Okay, so I'm just going to put some labels down here on the number line here. These represent the number of boxes of cereal that it would have taken in order to get that complete set of cards here. And I'm going to share some data from a previous year when the class did this and we kind of put it all together. Okay, 25, and I'm going to go ahead and throw 26 all the way, all the way over at the end here. That'll be 26. Okay, and then I'm just going to go through and I'm going to put, just on our dot plot here, the number of times the students would have reported out here what they would have gotten for this. Okay, just so you can kind of see how frequently this happened. 1, 2, 1 here, 2, 1, 2. I think we had one more there maybe. Okay, and 1 here, 1 at 25, and 1 also at 26. Now, here's what we're interested in. We are interested in anything that happened at 23 boxes of cereal or greater. Okay, those are the ones we want to know. Now, if I did this correctly, I wasn't fully, they're supposed to be on this 45 dots. Okay, so if I left one out, we're going to say there were only 3, though, in this range here. Okay, so we're going to say in 45 repetitions of our simulation, we had to buy 23 or more boxes of cereal 3 out of 45 times to get all 5 cards. Okay, so our approximate probability is roughly, okay, so we're talking about 3 out of 45. So if we divide that, that is roughly about 7%. Okay, that's roughly 7% there. okay? So now we have to decide, our conclusion is going, excuse me, going to be one of these two things, okay? If our percent is greater than 5, then our conclusion is this one down here, which is where we're at here. We should say that this person, she should not be surprised that it took 23 boxes to find all 5 cards, okay? Because the likelihood of needing to buy 23 or more boxes of cereal is above that threshold it's above that 5% threshold. So that means it's like, and if 7% doesn't feel like it's a very high chance, but 5% is our benchmark. So anytime a probability is over 5% in the stats world, we're saying that that is likely to have occurred by chance. If it's under 5%, then we're saying that's not very likely that it could have occurred by chance, and then maybe she should be surprised that it actually took her 23 boxes to get the full set. Okay. So in the previous video, we were initially posed with this idea that what's the probability that a student earns at least an 80% on a true-false quiz written in Chinese if the person taking the test doesn't know any Chinese, okay? Should the instructor be concerned about cheating? Meaning, should he be alarmed that someone was able to guess their way to an 80%? Okay. How can we simulate the probability of guessing 80% correct? Keep in mind, this is a true-false quiz. So it's kind of 50-50 here of you guessing it right. Okay, now we get to do a problem really from scratch here. So for the state part, we're really just kind of wanting to rephrase, like, what is it that we're after? Well, we want to know what is the probability of getting at least an 80% on a Chinese true-false exam if you don't know Chinese. Okay, so in other words, it's in a language you can't read, you have no idea what these questions are, you're just simply guessing. The way I could write this out in symbols is I could say X is greater than or equal to 8 if X represented the number of correct answers out of 10. So let's assume that there were 10 questions on this exam. What is the probability that someone would either get 8 or more? It said at least an 80%, 8 or more correct, okay? So the plan part of these simulations is where you have to write out a lot of details. Okay, so I'm going to go ahead and say we're going to use a random number generator. Okay, a random number generator on the calculator. So I'm saying what tool I'm going to use. Okay, and then I need to explain what my numbers are going to represent. Like in the previous problem, we let 1 through 5 each represent each of the different NASCAR drivers. Okay, remember this is a 50-50. Okay, so I'm going to let 0 represent a correct answer, and I'll let the number 1 represent a wrong answer. Okay, you're either right or you're wrong with your true-false. Okay, then I'm going to generate 10 integers. Okay, and these 10 integers are representing the question. So I'm going to generate 10 integers between 0 and 1. So I'm basically only generating zeros and ones, and that will represent the 10 questions. Okay, so I'm going to have a series of 10 zeros and ones, zeros and ones. What I need to do is I need to record the number of correct answers, which is the number of zeros. Okay, that's what I need to record. So in this plan step, you're saying what tool you're going to use. You're going to define what your numbers are representing. You're going to explain how many numbers you're going to generate, and you're going to explain what it represents and then what you're recording. Okay, and then you also should say how many times you're going to do this. So we will say we will perform 20 simulations, okay? 20 simulations. Okay, so down here, This is just the simulation number. We're going to do this 20 times, so I'm just going to fill in 1 through 20 in these boxes here. Okay. And then the second row represents the number of correct answers in 10. Okay, and keep in mind, a correct answer, we said up here, was a 0. Okay, so on my calculator, I would choose that random integer feature. I want to generate numbers from 0 to 1, and I would just do this. I could do this in sets of 10 if I want, or I could just keep hitting enter 10 times, and I'm going to record how many zeros am I getting out of 10. Okay, how many zeros am I getting out of 10? And so I'm just going to write some of the data that we got when I tried this here. The first time I got 5 zeros out of 10. When I did it again and generated 10 numbers from 0 to 1, I got 4 zeros. Okay, and so I'm just going to fill this in so you can see. Now, anytime you run this, you know, you get different options here. Okay. So there we have that, and now we're going to put this on a dot plot to kind of see this in action here. So I'm going to go ahead, remember my x-axis is the number of correct answers, whoops, space this out a little better, out of 10, okay? Number of correct answers out of 10. Okay, so there was one time where only one answer was correct, one time where 3 answers were correct. Okay, keep in mind, this is simulating guessing. There's a 50-50 chance of either getting a 0 or a 1. And if you're guessing, you essentially have a 50-50 chance of getting it correct, you know, true or false. Now, what are we interested in? Let's look back at what our state step said. We're only interested in what's the likelihood that you would be able to get 8 or more of the questions correct. So we want to focus on anything that landed at 8 or more. Okay, so we did this simulation 20 times, and only 2 of those 20 times were we really getting an 80% or more. Okay, so we want to spell this out. We just don't want to write 20% there. We want to say in our 20 simulations, okay, in our 20 simulations, we had, see how I'm using context here, we had a student get at least an 80% 2 times, okay? This is a 10% probability. Okay, remember that benchmark of 5% here. So because it's bigger than 5%, I'm going to say it actually is likely that this could occur. Therefore, the instructor should not be surprised, nor should he suspect cheating. Okay? He should suspect cheating if this probability was under 5%, because that means it would be very unlikely to guess your way to an 80% or better just by chance. But since that's above 5%, we're saying, okay, that's above our threshold here where it's likely that it could happen. Okay? So, I mean, not majority, but it's above 5% there. Okay. All right, well, that brings this to a close. I think there's a few problems.